Okay, so let's again imagine that we have a superposition for a particle in a 1D prison constrained to live between 0 and L, and that the state, the wave function, looks like this. Right, so it's a combination of the lowest energy level. Let's pull the A on the outside. Close it off there. So it's a combination of the first two eigenfunctions, the lowest energies. So let's look at, so this is psi of x and t, and let's think of the probability density. The point is that we want to see that in fact there is time evolution here. That there's a time parameter and that there is a possibility for dynamics, and that comes directly from the fact that we don't only have one value of energy, but we have a range of energies. And so in fact that dynamics, how quickly the system evolves, should depend on that range of energy. So we want to see this. So let's evaluate this quantity. So we need psi star psi. So what does that look like? So we get let's say A is a positive number. It's not complex. So instead of saying A modulus squared, we'll just square A. The first term looks like sine squared of pi x over L, plus we have the sine squared of 2 pi x over L, and the A is outside, so let's put the A side like that. And then we have two cross terms. So what does that look like? So we have sine pi x over L times the sine 2 pi x over L times e to the I times the difference between E2 and E1, t over h bar, plus sine pi x over L, sine of 2 pi x over L, times E, and if we insist on keeping it as E2 minus E1, then we have a minus sign for the other term, E2 minus E1, t over h bar. And that's it. Close that off. And we can combine the cross terms. So these two terms have the same f of x, right? Sine pi x over L, sine 2 pi x over L. And so we have an e to the, right, so let's notice that the time term is like an e to the I, let's call it a t, and we here have a term which is e to the minus I times at, and these can be written in terms of cosines and sines, right? So this is cosine of at plus I sine of at, and this is cosine of at minus I sine of AT, which gives us twice the cosine of AT. And so we end up with the probability density being A squared times the sine squared of pi x over L. All right, so we have a term, or rather two terms, that don't have any time dependence in them, plus 2 sine of pi x over L sine of 2 pi x over L times the cosine of this term we called A, which involves a difference in energy. So it's E2 minus E1 times T over H bar. So we really should put a different parentheses out here. And close it off like that. So this is the probability density, and we see that in fact it involves a time term, and it's a cosine of a time term. So the probability density is oscillating sinusoidally at x values, and the frequency of oscillation depends on the energy difference. So the larger the energy difference, the larger the frequency of oscillation.